Hello, thanks to everybody to be here. I am Santiago Blanco from the DNVGL, and we will present our vision of the potential of distributed energy to tackle the climate change. First of all, as the DNVGL, our main goal and our main vision is to solve the energy trilemma. And today we will talk a lot about how to solve the energy trilemma. And it's good to remember that the trilemma is about first sustainability, and from our point of view, this is a mandatory rule from now to focus mainly and I hope only in sustainable energy, but also to take in consideration the reliability of the network and the impact in the network of the different kind of renewable that we integrate, and finally to ensure the efficiency of the system, the affordability of the system. The main discussion that we have now is between centralized level and decentralized level renewable integration. And this is a hot topic in the market now, and I think that this is a very interesting discussion to have today. First of all, it's important to remember that the prices of renewable energy, mainly at the utility scale, but at both levels, are falling dramatically. And the present prices for some recent PPAs, like the examples in Peru or in Mexico or in different American countries and Middle East, are showing a dramatic reduction of the price, and this is something that we have to be happy. And in the future, we expect that will continue in the same way. Clearly, talking about distributed generation, solar PV is the main technology, and solar PV both at the utility scale, commercial and industrial and residential level are reducing the cost in more than 10% per year, almost 15% per year during the last 8 years, and this is something that is clearly impacting in the market and changing the whole paradigm in the industry. If we talk about distributed generation, obviously grid parity is an important topic to discuss about. If we compare the levelized cost of the energy, the rooftop energy, with some retail markets, this is a Deutsche Bank report showing that several countries in the world or regions of countries in the world are achieving the grid parity, but we have to consider not only the grid parity of the cost of the energy in an isolated approach with the system, because we know how the system works, we need to consider the whole system vision. And one of the main priorities of our study has been to consider not the customer itself focus. For us, it's very important to consider the whole picture of the system. And I think that all of you are very familiar with the duck curve, showing that in the future, this is an example in America, in California, showing that the high penetration of solar will produce a big reduction of the demand of energy during the day. But in terms of the peak demand, and all of us, we know that the peak demand is the main driver of the definition of the system, both for installed capacity and for the network itself, will continue basically the same. So the integration of solar PV will have a big impact in the demand, but not in the peak demand. And then the cost of the system will remain basically the fixed cost, basically the same. Obviously, this could change in the near future because the evolution of energy storage at the present is very, very promising, and we expect to continue following the same path that solar, and this will change some of the studies that exist in the market, and we need to be very, very, very careful about the evolution of storage, because will be a big impact there. I think that if we discuss about grid parity, the case of the German market is a good example, because we are basically comparing the cost of the solar rooftop PV here with the tariff in the market, the price of the energy in the market. But it's convenient to remember that this price is not only considering the cost of the network and the cost of the generation itself. It's also considering other tax and surcharges based on the system itself. And to be fair with the comparison between one technology and the other, perhaps we should compare this with this. And in this case, the grid parity is still a future. I like to here remember a couple of documents that are very important for us. One is the European recommendation, the framework strategy for a resilient energy union, with key topics that is convenient to comment. No? First of all, we need to empower the customers, and we need to think in the customer in a completely different way than in the past. But at the same time, we need to take care to move away from any fragmented system and coordinated national policies, and to recover the idea of an integrated, in this case, European system. No? So obviously here we are talking of a system. In this case, not a country-based system. We are talking of a European system, and this is very important to remember. No? An additional important document to remember is from the United States. In this case, from the New York Public Service Commission, with the idea of a new player in the market, or a new role in the market, the role of the DSO to develop and operate the platform needed to empower the customers. No, the so-called here distributed system platform. No? If we want to really be aggressive in increasing the integration of distributed generation, we need to also consider the network and the need to improve the technology, the procedures, the organization, the framework, the regulation of the distribution to support this new role. No? We as DNVGL recently, last year, we developed a very interesting study that is available in this link. It was a theoretical study, basically with a system-based approach to compare the system cost of distributed and centralized renewable generation. In this case, it was pure renewable, basically wind and solar, but combined with some CHP, and was a marginal approach because our study was to evolve how to add to the system 10% of new renewable in two scenarios. One, to cover 10% of additional demand, or other, especially for European countries, to replace 10% of the demand because of the phase out of 10% of conventional generation. No? To do this study, we considered three main centralized or utility scale generation: pure onshore wind with a solar, a mix of wind and solar, 80-20, and pure utility scale solar, are the three main technologies to compare. And we compared them with a distributed generation, small size PV, small scale PV, one of the cases, small scale PV plus micro CHP, mainly for the countries with low irradiation, and a small scale PV plus storage. To do the study, we evaluated at a system level different theoretical markets, basically based on the generation flexibility, penetration of hydro, and also renewable penetration. No? And we identified different types of markets. And we also evaluated at a distribution level, basically because of the solar irradiation that has a strong impact in the study, and also obviously the network topology, trying to divide the European network with longer low voltage networks, with American and South American networks with shorter low voltage networks. No? To do it, we defined 6 kind of theoretical markets, one with low flexibility, low hydro, low renewable integration at this moment, low irradiation, and a European network that could be similar, perhaps. It's difficult to say this, but could be similar to the French market. Another scenario, another case could be same than the other, but with high renewable integration, that perhaps will be the British market, not at the present, perhaps in the next years. Other one was to consider a mid integration of renewable, with low renewable integration now still and low irradiation, but with an American market. That is basically the case of the northeast coast of the American market, mainly the New York State. Another one was the mid flexibility and high renewable integration with high radiation and European network. That is basically the Spanish case. And the other two were basically something similar than the Brazilian case, another similar than, for example, the Uruguayan example. And the result of the study with these 6 cases were that the centralized generation were always lower than distributed, but as you can see here, the difference sometimes is quite small, and in other cases is bigger. No? More than the numbers itself, because obviously the numbers are the result of a lot of assumptions, and we can discuss a lot about them, are some comments about the results. No? First is that still now the utility scale renewable is still the more competitive technology to integrate in the network, and this is something that I think that most of the market report support, and we need to remember this, and this is very important. Second, that within the distributed generation alternative, small PV and small PV together with battery are the most competitive. But obviously, in region with low irradiation, small P plus micro CHP is very interesting. And finally, that the evolution of the cost of storage will be perhaps the variable with more impact. And finally, an interesting outcome was that the system integration costs were quite low compared with the rest of the system. So the system integration costs are not relevant compared with all the others. No? So additionally, we evaluated another scenario, completely different, with a not developed network, non-electrified network, and in this case, the result was different. In this case, the result was that distributed PV is a very, very, very interesting technology in this case to cover the demands of regions without a network at the present. So, to end the presentation, we have only 10 minutes. There is a big discussion about centralized or decentralized, and our position is that we need to think more in collaboration instead of competition, and we need to develop the national and regional framework to continue supporting the competitive utility scale renewables, but at the same time to keep the focus in the integration of the network. For example, in the case of the European market, the integration, the interconnection between the different countries are relevant. And a lot of innovation will be needed in the definition of the regulation of distribution to support the deployment of distributed energy reserves as part of a smart grid approach, and also promote the participation of the distributed energy resource in the market locally and globally will be important with new resources like electric vehicle storage and demand response that will be very, very important in the near future. And finally, we think that will be very, very important to send real signals, clear signals to the customers about the real cost of the system and the different technology to move in the more competitive, sustainable, and reliable future. Thank you.